thank you for everyone for coming along and listening to this panel. My name is Mark Campanale. I chair a non-profit financial think tank called the Carbon Tracker Initiative, mostly ex-City of London analyst studying the energy transition. I spent 20 years in the City of London as a fund manager analyst, investing in the green economy. I was thinking this morning about how best to open this, and I'm not the first to say this, but I thought it was a profound observation that this generation, the generation now and coming, is the first in human history to heat themselves and use transport and power without the necessity of burning something. So if you think of the caveman in Neanderthals, if you wanted heat, you burned something, and then into the internal combustion engine. If you want to move from A to B, you had to burn something. And even today, the dominant form of energy generation still involves burning something. So the energy transition will have the first generation of humans that could do all of those things without setting something on fire. I thought, well, that's an extraordinary insight into the significance, the importance of what we're going to talk about on this panel. So the energy transition covers so many different things, but key to it, I think, have been technological breakthroughs, whether it's in solar, costs down in solar of 70, 80%, battery storage, the other big one that's crucial, wind, and clearly. So now I think it's around 80 to 90% of the world, clean energy is the cleanest and the cheapest form of power in 90% of the world compared to fossil fuels. And that's all really happened because of the work of scientists, of academics, importantly of investors to back key technological breakthroughs. And so when I look at my panel, I'm trying to get my head around some of these key technologies that we've heard about. Some of them are fairly traditional technologies like geothermal energy. When I was at Jupiter, we backed some of the first geothermal energy companies back in the early 1990s. Today, we're going to hear from geothermal energy. We're going to hear about hydrogen. There isn't a government minister who's involved in climate that isn't jumping up and down about the potential of hydrogen. And I know that a couple of big investment funds are being raised in the City of London now to back the hydrogen economy. So we want to talk a little about hydrogen. Apparently, we've got to talk about fusion.
Yes.
You're going to have to help us understand what this is, and are we going to blow up or not? And of course we won't, but you're going to have to explain to us in clear and simple terms, because it's all a mystery to me. And Amit, thank you for joining us today and helping us to introduce what Field does and around battery storage technologies. So I've asked everybody to speak for 4 minutes, and they're all going to follow the same pattern, who they are, what they do, and I want them to explain why their breakthrough is something that should capture the attention of the Sunday Times business section next weekend, because we want to be reading about what you're doing so that the world can understand what you're up to. So let's go to you first. So hydrogen, what parts of the value chain are you involved in, and do you think of it as a breakthrough, or are you just taking existing knowledge and expertise? Have you got a special insight that makes your company and what you do a little bit different?
Okay, so let's start from the beginning and answer each question separately. So I run a company called H2Go Power. It started 7 years ago when I was still a PhD student at Cambridge University. The core technology came from my PhD, and it was, I wouldn't call it a breakthrough, but it was a new technology or a new approach to store hydrogen. Instead of storing hydrogen molecule as gas, because of all the safety and cost associations with that. Back in the days, I had an idea on how to chemically transfer that into a solid state and store it there for as long as needed and only release it back as a gas molecule when the demand peaks. This was the idea then, but then having started H2Go Power, which is 7 years old today, over time we basically looked at how we can scale the technology to basically capture renewable energy for long durations in the form of hydrogen. So we use a solid state system. The business have evolved into an engineering business whereby we look at how to automate the process, how to store hydrogen intelligently, whereby you don't just want to generate hydrogen or just to store it. You also want to do that intelligently based on what's happening in the market. Whoever is generating hydrogen at the cheapest prices, it makes sense to store it then. It makes sense to generate hydrogen when you have, say, surplus renewable energy where the cost point there is zero or sub-zero, and also release it when the demand is high and when it makes sense to convert it back to electricity if you want to sell it as electricity rather than as a commodity, as a hydrogen. So this is one of the markets that we look at. The second market that we look at is drones, basically, and this is to replace or come with an alternative to what lithium-ion batteries are limited for, which is storing more energy per unit volume at a weight that is light enough to allow a drone or an eVTOL to get off the ground. So basically, we're able to store 3 times the amount of energy in the same unit volume as typical lithium-ion batteries. We use them for drones. These have been successfully demonstrated, and we're working on the second generation, which will be tested for flight by the end of this year.
Fantastic. Could you tell us about that pilot project on hydrogen that you've got going? Where is that, and who are the customers? And I suppose in the hydrogen story, it's all moving quite fast. How are you looking on cost parity on costs? Is it a case of doubling and tripling in size and then cost reduces? Is that the pathway that you're following?
So let me start with the cost question, and we'll go back to your first one. Cost question. It's a little complex based on what you compare it with. So if I only want to talk about the cost of storage, and I'm comparing it with compressed hydrogen cylinders, which is the conventional method to store hydrogen today, with the 55% of the storage cost has to do with the compression, which is a very expensive process. So because we don't compress gas, we don't store gas at 300 bars or 700 bars, we convert it chemically. We eliminate that 55% of the cost from the storage equation, which means that we're reducing the cost of storage. We're enabling the hydrogen to be stored for longer durations, and at the same time converting the whole process into a safer a process to scale and work at tons of hydrogen stored per day or so. So this is the cost comparison one-to-one with compressed hydrogen storage. But if you'd like to look at, say, energy storage or the cost of hydrogen, green hydrogen or blue hydrogen, the conversation goes on. And there are so many comparisons that you could make. But bottom line, the cost of green hydrogen, which is hydrogen that is generated renewably, will meet parity with, say, blue hydrogen or other sources of storage when the demand is created and the market is in a stage where the momentum will drive demand. Governments around the world are committing to strategies that will enable that, and I'm very positive about seeing intent.
So that's great. This is my last question, because I'm seeing a lot of us. We're so keen to see hydrogen succeed and be part of the green economy. And you talked about demand and government policy, and I completely agree. That has to step into place. Are you seeing in your board and your colleagues, are you seeing a pathway to that coming through? Or is there some apprehension that actually it may not come through? You are? Okay.
Yeah.
Well, fantastic, because that takes us a long way to addressing the climate challenge if everything you said is correct, which I believe you'll do. So I'm going to be looking up H2GO power on the internet, checking out a little bit more after this conference finishes. So thank you very much for that. Igor, I'm going to turn to, I said earlier that geothermal energy has huge potential, and whether you're down in Cornwall or I know in Slovakia or in the Pacific Rim of Fire, which you all know about, it's historically had its challenges, but it's managed to compete quite well in places like like California. Can you tell us a little bit more about GA Drilling's insight or technology and what makes you a little bit different?
Yeah, thank you. First of all, my pleasure to be here in person after some time. Hopefully it will stay so. What does it mean today's energy mix? If we look to that in overall, even we are doing a lot of things now, that still it is not enough to convert and fight the climate change from the perspective of the change of the energy mix to transform it in the next 20 years. And even as we are supporting many kinds of the projects and energies, there is one significant, let's say, the gap in that portfolio is that we don't have a solution that can one-to-one retrofit easily the big coal power plants and this fossil fuel energy, because it needs to be baseload. It's named like, or it's a typical 24/7, so you can switch it off, switch it on when you need. And today's energy mix from CleanTech is not allowing that. You need the daylight or you need the wind blow. And in this case, we were fascinated some 10 years ago when we visited few places in the world, like Mark mentioned, in Iceland or in the West US. They were generating the energy from the geothermal. But then we recognized the biggest problem of the geothermal. It is not a surface part, turbines and so on. It's quite standard. You can see it. But the problem is the drilling, the wells, and the cost of the geothermal that is very expensive. And this is the main problem, that today's all the drilling technologies, they are driven by the oil and gas business, oil and gas companies. And they develop the technologies that are drilling in sediments, in soft rocks. And they didn't make too much R&D in the hard rock drilling. If you need to go to the high temperatures that you can bring the hundreds of megawatts to the surface, not talking about some small cottage that you need to heat, but really about the big parallel to the fossil fuel industry, you have to go much deeper. In Iceland, when they are sitting on volcanoes, it's easy because you can drill by this conventional technologies to 2-3 kilometers, and you can build the power plants for hundreds of megawatts of this baseload energy. But here, for example, in London, for the same energy, that's great that you have this big thermonuclear reactor, is the Earth. You are able to get it here, but you have to go deeper to 8, maybe more kilometers in the future. And that was mission we took a few years ago. We spent then 5-7 years in fundamental R&D, and we developed a very new technology that will make disruption in the drilling industry, and it's based on the plasma. So you can imagine like plasma drilling, like flashing the very hot stream of the water, like with the temperature of the sun against the rock, and rock is crumbling to small pieces, and then you can remove it by the conventional infrastructure that there are billions invested today in assets in this drilling world. And for us now, where is the momentum to go further, is that this drilling and oil and gas industry was doing a lot of greenwashing last several years, but now that they really took this transition seriously as they see the market when it's moving, and I think the geothermal is one of the best options for them to transform. For us, where we are as a company, we have the headquarters in Slovakia and Bratislava, but also here all the design team in the UK. And now after a lot of trying and the tests that we provided in the test facilities, we are now moving to the field. And here we are first connecting with the industrial companies when we already have in our cap table few venture or the industry investors. But now we are focusing mostly also in this round for the climate investors to have it about 50-50, to be able to make the first pilot and then to be able to make a geothermal anywhere.
Where's the first pilot going to be?
Pilots, we have several candidates, both in Europe but also in the US. There is a big traction in the US, again, from the oil and gas industry to do something real green. And they have the expertise and they have billions in assets. So this is an advantage that we can offer them by bringing the new technology, this shift.
Yeah, I like that idea to get people off oil and gas drilling and into plasma drilling, which still sounds complex. Is it costly compared to, say, conventional geothermal energy of what you're introducing? Is your case that it's a price competitive advantage, or are you saying that this 24/7 energy to me is constantly available to meet demand? Is that what you're saying is your special advantage?
Great is that both. It means that in the end, the energy is 24/7.
Yeah.
But what we are doing, that we will be able to drill to deep depths with very much highly competitive price than today. And not only that the price is better, but we are opening totally new markets from 3% today as a geothermal globally of the area. We are able to expand it to 70–80% of the areas, including like London here and so on. And this is the big change for the price that doesn't need any subsidies. So it's very competitive also to the coal, because our aim is not to fight with solar or wind. Our aim of the geothermal is to fully prepare the solution for the conversion of the coal and the oil and gas industry to the renewables.
Thanks very much for that introduction. And I just wonder whether cheap hydrogen can be a byproduct of geothermal engineering, but
one of the outputs.
Is it really? I mean, that's fascinating. Again, another area, a completely new area to explore. So
could also store it cheaply. So there we go.
So we've got this sort of geothermal energy and hydrogen together. Well, fantastic. That's one to think about further. So if I can turn to Moritz, fusion. I mean, this panel isn't turning into a competition, but we've heard some fantastic, compelling stories from geothermal energy and from hydrogen, and now we've just heard how we're going to combine the two. Where does fusion fit in? And I mean, it sounds complex, or are you saying, can you introduce it to us? Because I'm sure a lot of people will be very unfamiliar with what your company is doing and also the background to your technologies.
Yes, Mark, thank you. Good morning, London. It's amazing to be here and to give you an insight on what we do. To start out, I'd like to give you some interesting facts about Germany. First fact, we're not very funny. What you don't know is that to electrify our mobility, so just simply having cars and trains run around the country, we would require 110,000 windmills running at 2,000 hours per year. Currently, it's less than 30,000 windmills running at around 1,200 hours a year. A single chemical plant of BASF in Ludwigshafen, arguably the largest in the world, we would need 7 conventional fission plants to decarbonize 1 chemical plant. So while everything we do on this planet to fight climate change across all of the efforts that we'll hear about today that are desperately needed and that we need to where we need to increase speed, there is another fact about Germany. Yes, we're only 1% of global population. And when we scale that up to a global scale, things become much worse. India is going to overtake China as the most populous country in the world in 2027. China is currently planning or building already 300 coal plants, and India is building or planning 400. And in Germany, we're arguing whether a windmill should have a 1,000 or 500-meter distance from the next town, and we're arguing whether 1 coal plant will be switched on or off in one of the states. So going to global scale and looking at the most optimistic studies, we see that all of the renewable efforts will be able to supply about half of the global energy demand in 30 years. And those 30 years are the ones that count. This is where we have to make it happen. And therefore, I think there's 2 distinct routes that we can go down. One is fission, which we know is working, and which we're currently making safer through molten salt technology that takes care of the meltdown risk. Unfortunately, there's still a nuclear waste, and that simply threatens the commercial viability of any fission plant. Or we can make fusion happen and be able to complement all of the renewable efforts on this planet with a high-density energy source that is capable of powering industrial processes in scale. 1 mass of our fuel of hydrogen, proton, and boron-11, we're able to extract 1 million times the energy compared to petroleum. So it's extremely high-density energy option. Unfortunately, it's very hard to get to, and thankfully, we've already made some progress on it. In our concept, we're using high energy lasers to deploy energy in a small 1 millimeter target that contains our fuel. And we're creating extreme physics in this fuel, creating a plasma. The laser, in about 50 femtoseconds, so we're talking 50 trillionth of a second, deploys more energy than the currently installed energy on this planet. And this creates some very extreme conditions that allow us to fuse a hydrogen proton with a boron-11 nuclei, reacting to 3 helium alpha particles, and we can harvest the energy of these positively charged particles through magnetic induction. We're at a point where we have a very large and complex computer simulation that shows very, very positive results, about a factor of 300x over the conventional deuterium-tritium approach in fusion. And we're now expanding our experimental campaign after shooting a campaign in Osaka, Japan, and at the Colorado State University. We're now moving to a facility in Munich and to 3 facilities in the US to validate this experiment. And hopefully then in the next 2 to 3 years, we'll be at a point where we have proven the key assumptions, key results of this model, to then move on to building our demo facility. And it's great to be in the UK because we're actually in talks with the UK Nuclear Authority, whether they may be giving us a new home here after they learned general fusion with a magnetic confinement approach to build their demo facility here. It looks like they want to bet on the race rather than the individual horse and accommodate separate technological approaches to fusion. And that'd be an amazing next step to then show energy gain en route to then building power plants in the gigawatt range 10 years plus.
Brilliant. Well, look, that sounds fascinating. The idea of extreme physics, if you think of the phrase you used, I mean, that's, well, if you can get to the end outcome that you're looking for, I mean, good on you, but it's obviously going to require a huge amount of support and investment. I want to turn to Amit now, Amit, to understand the role of field. And we talked a little about different types of energy systems, geothermal energy, on what we're doing in hydrogen. Yours is a focus on the role of storage, if I understand it. We'd love to hear more about what you're doing.
Yeah, thanks, Mark. So Field mission is to finance, build, and operate renewable energy infrastructure globally. We're starting with grid-scale battery storage in the UK. So the renewable energy transition is huge. The numbers that you mentioned are huge. Huge amount needs to get built over the next 30 years. But the real enabler for the technology that exists now, solar and wind, is battery storage. Grids at the moment, you have grid in the UK has something like 40% renewable energy generation as a percentage of the whole of all of the generation in the UK. To really take that from 30 to 40% up to 70 or 80%, you need to be able to store that energy to use it when you need it. And right now, you know, where we are in the UK, that's a real struggle. So you've probably seen headlines about energy crisis right now. The battery storage and, you know, a much higher penetration of battery storage right now would have gone some way to helping dampen some of those really high prices in the peak periods. So what we're doing is we're financing, trying to be innovative in the way that we finance these projects. So we will, be looking to more diverse pools of capital rather than, just standard infrastructure capital, which Mark, as you know well, will, a lot of that will have been, can be quite conservative and sort of focus on asset classes that it knows well, rather than looking at new asset classes like battery storage, where the technology is very much proven. It's lithium-ion.
Yeah, on technologies, there's so many different types of battery technologies, and we're hearing breakthroughs all the time. Yeah. I mean, it's constantly changing. I mean, how do you feel confident that I don't know where your thoughts on lithium, and we're hearing of others where, are we settled on the technology on batteries, or do you think we're going to see an awful lot more change in the next 5 years?
We're definitely going to see a lot of change. But the leader by a long way right now is lithium-ion, lithium ferrophosphate batteries in terms of production lines, scalability, cost. That's the thing that's ahead by a long way.
And on the scalability, is it just a matter of doubling the amount of batteries and you get your 20% cost reduction, or are other factors going to come into play here?
Yeah, it's increasing the density,
okay.
which leads to it. So, those costs will continue to decline over the next 10 years. Some of the supply chain might increase in cost, though. So if you use up a lot of the lithium and other materials that go into it, you could increase those costs. But what we want to do is be financing, when other forms of batteries become economic and other forms of storage in time, so hydrogen, for example, we'd look to finance those assets, build those projects, and then importantly as well, monetize them. So actually trade the energy from these assets. That's something that infrastructure investors often will hand over to someone else to manage for them.
Yeah, we know you know a little bit about energy trading, so I think you've probably got a bit of advantage there.
Well, hopefully. But yeah, it's I think integrating that all into one is really important, and really key thing I think is unlocking finance. There's trillions of dollars lined up to that's pointed at the renewable energy transition. But when it comes to actually financing the assets, because it's a new asset class, something like batteries are complicated, the revenue streams can be complicated. It's often seen as a high-risk asset versus something that's funded before maybe a gas plant or a gas peaker. And so I think really unlocking finance to this by innovating in the way you finance it, but also in the way that you monetize them is really important. That's what
Great. I mean, I wish I'd left more time for questions. I know I wanted to hear you all speak, but I've got a few minutes for questions. Did anyone want to raise a burning question to anybody on this panel? This is a keen audience. Where's everyone listening? Okay, go ahead, please. And if you could just say who you are.
Yeah, hi, morning. My name is Ross MacDonald. I'm here with a Founders Forum student competition. I've got a question about the geothermal energy idea. What scope is there to retrofit existing power stations and grids with that technology rather than build new systems from scratch? And how might that help the sort of rate of adoption?
Thanks for that.
I don't know if I heard all question, but you asked about the grids and the fit of the geothermal for it. Yeah, that's I think one of the greatest point of geothermal, that is as it is baseload energy, it has same characteristics as the fossil fuels, like today's conventional, like gas or the coal. So it's a relatively easy solution for retrofitting. For example, coal power plant, you have a lot of land. You can then easily build a geothermal plant there in this same territory. Advantage of geothermal is that 95% of the infrastructure is hidden. You have only a very small footprint at the surface, and all the rest is below the ground. And then you can, of course, simplifying this, just plug it into the grid. Because it's 24/7, you don't need some special smart grid or some storages. Of course, for geothermal, ideal is to be distributed. What is also advantage, that you don't need to build one very concentrated source of the energy, but you can use it anywhere, and also for the heating, because this is only renewable that can deliver directly through the winter, the heating that, for example, in Europe, we are using 50% of the energy for heating.
Great. We've got 1 minute to wrap up. How are these technologies going to work together? I'm interested in, obviously, the hydrogen and the storage systems, and we've got this outlier called fusion. I mean, if we just wrap up your, just 10, 15 seconds each of your last comments, Amit, on how you see this interacting together.
Yeah, I think we need better baseload sources of electricity, and I think that's what I understand, geothermal and fusion will provide. But then you need storage to manage peaks. That's the thing about electricity, is it peaks and troughs a lot, and that's where you need things like hydrogen, other forms of storage. So, but all these things moving together, I think, will really that provides the new paradigm.
Great, Moritz.
Yeah, I think adding to that, it's, complementary. Our market entry is going to be from the top, so super large scale demand for industrial processes, decarbonization across steel, aluminum, building materials, chemical plants, and providing gigawatt high density solutions that can power those processes, and that will be required in order to decarbonize our energy consumption.
Igor, you described geothermal, or rather the planet, as a huge geothermal reactor, which all this potential free energy, whether it's from the sun or the wind, you're saying it's from the Earth and the Earth's crust, which is extraordinary. You have great confidence in this technology. How is it going to fit together with some of the existing? Do you see it as essentially displacing coal-fired power in situ and avoid the retrofitting problem?
I fully agree with predecessors, because what we are missing is a real renewable baseload source. That's something that is not currently for the big industry, big consumers available. And then you need, of course, how fit together is then you need portable solutions. You need solutions when, for example, some kind of energy, you cannot install it from some reasons to bring it there, to store there. So it's something that also it's working like for base load during the night, because for electrical vehicles, that's fine, you can drive through day, but you are charging typically in the night.
And Anas, I feel somewhat that, you're the last word, that hydrogen is going to play a very, very important part in the energy transition. I'd love to hear your concluding thoughts on, and is H2 Geopower going to be one of the leaders in this? I mean,
we're still everything we do is work in progress.
Right.
The industry is being created. The momentum is quite impressive. So I'm very positive that we will play a part. Not sure yet how big, but hopefully will be big enough to justify claiming leadership.
Brilliant. Well, look, thanks very much for this panel, this panelists, and you've all got an exciting future. And Maurice, you gave this rather gloomy 30 years. We've only got 30 years to do it, but I've heard enough here to make me think that actually we've got the new technologies and the potential breakthroughs to get us there before we crash out beyond that 30-year period. So thank you very much.
Thank you, Mark.
Thank you.